Okay, here's the homework for today. It's not going to be due until Wednesday. So let me write that down here. Due Wednesday, November 4th. Alright, so it's not going to be due till Wednesday, November 4th. So if you were in class, I did say it was due on Tuesday, but it's going to be due on Wednesday. These are the 6 problems. I want you to be able to put each one of them in interval notation, and I want to see evidence that you plugged in values to check your intervals. There's either going to be 3, sometimes 4, even 5 intervals you're going to have to check. So the people who took the sheet of paper that I wrote this homework assignment on probably are not going to have room on the paper. So those of you who are watching this video, you're going to need room for each one, right? So write these down. I'm going to go over 2 of them. Okay, let's go over number 1. First things first, you want set equal to 0. Check, it's already done. You want to have one fraction on the left-hand side. Check, that's already done. So now you can go ahead and set your denominator equal to 0. In order to find the x-intercepts, and also you want to set your denominator equal to 0 to find where the value of x or values of x that would make it undefined. So I'm going to solve for the x-intercepts here. We're going to have 4x is equal to 8. 8 divided by 4 divided by 4. We get x equals 2, which again is not necessarily a solution, but it is a critical point, because remember we have to find our critical points. And x equals 7. That really x does not equal 7. It is a critical point, but remember it is going to make our denominator 0, and we don't want that. So it will be undefined if x is 7, but that is a critical point we need to look at. So now we're going to look at our number line, or make a number line. My values are 2 and 7. So I have 2 here, 7 here. So I have 3 intervals to check. 1, 2, 3. All right, so in this one, I'm going to check, I'll just check 0. In 2 through 7, I'll just check 3. And above 7, I'll just check 8. So I'm going to plug these values back into the original inequality. So I'm going to go ahead and erase this now. I have my critical values. So I'm going to plug in 0. So 4 times 0 minus 8 all over 0 minus 7. Is that greater than or equal to 7? 4 times 0 minus 8 is negative 8 over negative 7. Is that greater than or equal to 0? Well, both of these are negative, which makes this actually positive. And that means it is greater than or equal to 0, because anything positive will be greater than or equal to 0. So that is check. Now I'm going to plug in 3. So I'm going to erase this and plug in 3. So 4 times 3 minus 8 over 3 minus 7 greater than or equal to 0. 12 minus 8 is 4 over negative 4. Is that greater than or equal to 0? Well, negative 1 is not greater than or equal to 0, so that's no. So I'm going to come here, X that. That interval does not work. And then I'm going to plug in 8 for my third interval. Check that. Okay, not working right here, so erase it all. Alright, now I'm going to plug in 8. So I'm going to have 4 times 8 minus 8 is over 8 minus 7. Is that greater than or equal to 0? Well, 4 times 8 is 32. Minus 8 is 24. All over 1. Is that greater than or equal to 0? That is a yes. So that is a check. And if I was going to do a number line here, I would have at 2, it's going to be a filled in circle with everything this way. Nothing in between 2 and 7. And then after 7, now here's a trick. The fact that it is greater than or equal to, you would think you need a closed circle. Well, remember this value of 7. This is going to make this fraction undefined. So 7 is actually not a value, not a solution. You have to be careful, because I know in the past you've been accustomed to looking at the inequality, and if there was a line like this one under the inequality making it equal to, you would have a filled in circle. Not here, not in this case, so be careful. All right, so that would be the number line. And I did ask you to do them in interval notation. So for the first interval, you would have from negative infinity, always have parentheses around infinity, all the way up to 2 with a bracket. It does include 2. And union, or 7 with parentheses all the way to infinity. All right, so we have that for our first one. I'll come back and do another one. Okay, let's look at number 5. All right. Good thing to do would be to factor the top. That's going to give us x minus 4 and x plus 2 on top. Excuse me. And x plus 4 on the bottom is greater than or equal to 0. Remember, we're going to now set the top equal to 0 to find our x-intercepts, and then the bottom to find where it is undefined. So x minus 4 times x minus or plus 2 is equal to 0. So we have x minus 4 equals 0, x plus 2 equals 0, so we have x equals 4, x equals negative 2. Critical values, both of them, and the bottom, we have to set the bottom equal to 0. So x plus 4 is equal to 0, minus 4, x equals negative 4. So our three critical values are 4, negative 4, and negative 2. So we're going to check those. That means that this time we are actually going to have 4 intervals to check. And we'll see that on the number line. So as I draw it, we have negative 2, negative 4. So from left to right, we have negative 4, we have negative 2, and we have 4. All right, so we have intervals we need to check. So let's check negative 5 in here. In between negative 4 and negative 2, well, not many choices. You don't want to choose a decimal, so let's just choose negative 3. In between negative 2 and 4, you know, we always like to use 0, so we use 0 there, and after 4 we can just use 5. Wow, that's a lot of stuff to check, but we can do it. Alright, so erase this now, and plug in these values. So negative 5 squared minus 2 times negative 5. I'm going to show you a quick way to do this if you have access to a graphing calculator. Tomorrow in class, we will go over a very quick way to do this. But it is necessary that you are able to do this if you are asked to. So it's going to be 25. Negative 2 times negative 5 makes it plus 10 minus 8 all over negative 1. And on top, we end up with 25 plus 10 minus 8. So that's 35 minus 8. 27, I believe. Check my work. Is that greater than or equal to 0? Well, if one of them is negative, which this is, that makes the entire thing negative, which means it cannot be greater than or equal to 0. So our negative 5 does not work. Let's now try negative 3. So we have negative 3 squared minus 2 times negative 3 minus 8 all over negative 3 plus 4. Is that greater than or equal to 0? So I'm going to have 9 plus 6 minus 8 all over 1. So that's 9 plus 6, 15. Is that greater than or equal to 0? So that's 7 over 1, greater than or equal to 0. That is a yes. So we can check that off. That's yes. All right, now we're going to check 0. 0 is always an easy one to check. So that should go quickly. All right, plug in 0. So we have 0 squared minus 2 times 0 minus 8 all over 0 plus 4 is greater than or equal to 0. So we have negative 8 on top and 4 on the bottom, greater than or equal to 0. Well, a negative divided by a positive, that gives us negative 2. And that is no, that is not true. So that interval is not, does not make it true. Erase this. And let's check our last one, which is 5. So I have 5 squared minus 2 times 5, minus 8, all over 5 plus 4, greater than or equal to 0. So we have 25 minus 10 minus 8, all over 9. 25 minus 18. Do that again. 25 minus 18, well, 25 minus 10 is 15, minus 8 is 7 over 9. Is that greater than or equal to 0? Well, only way it can be less than 0 is if it's negative. 7 over 9 is not negative, so that checks out. Okay, now we can do our interval notation from here. If you were going to do a number line, you would take this and say, okay, negative 4. Now, I know, again, it's a greater than or equal to, but at negative 4, our denominator will be 0. So we have to have an open circle at negative 4. All right, and everything before negative 4 didn't even work anyway. If we look at our interval here, when we checked it, that didn't work. But everything from negative 4 to negative 2 did. So negative 2, you would need a filled circle. But negative 4, you will not, because it will make the denominator undefined. So we have that. Then from negative 2 to 4 does not work. But from 4 to infinity does. So let's write that interval notation. That's going to be negative 4, 2, negative 2, union 4 to infinity. There we go. If you have any questions on that, just let me know.